So when k fall in B, it is mk cap minus mk cap delta xk less than or equals this one. So which equals 2k into sigma over k fall in B, sigma over k fall in B 1 into delta xk. Okay. But we know that. What is 1? Modulus of mk minus capital mk by delta greater than or equals 1. So which equals 2k into, that is sigma over k fall in B, capital MK minus small mk by delta is strictly less than delta into delta x. Okay. So that means 2k by, that equals 2k by delta into sigma over k fall in B mk minus mk. Sigma over k fall in B, capital MK minus small mk. What is capital MK minus small mk? F is integrable on I, so it is capital MK minus small mk, that is less than delta, means it is UPF minus LPF. So it is UPF minus LPF sigma over k fall in B, capital MK minus small mk into delta xk is nothing but it is UPF minus LPF. Why? Because F is integrable on I. Agree? That is, which equals 2k by delta into what is UPF minus LPF? By the choice, it is less than delta square. So equals 2k into delta. Okay, 2k into delta. That is strictly less than 2k into some epsilon dash. Why? Because epsilon dash is chosen as delta strictly less than epsilon dash. Now, consider UPH minus LPH. That's our requirement. What is UPH? UPH minus LPH, which is equals sigma over k fall in A, capital MK cap minus MK cap into delta xk, capital MK cap minus small mk cap into delta xk plus sigma over k fall in B, capital MK cap minus small mk cap into delta x. Agreed. So what is this one? The first one is epsilon into B minus A. Okay. What is the second one? Plus 2k epsilon dash. 2k epsilon dash. All of these are positive quantities. It is treated as some epsilon 1. So UPH minus LPH strictly less than some epsilon 1. UPH minus LPH strictly less than epsilon 1 means by the Raman's criteria, then H is integrable on I. What is H? Why? Because P is the partition of I. So H is integrable on I. What is H? That is phi composition F. Then thus phi composition F is integrable on I. So this is the composition of a function. Means F is integrable, phi is continuous. Then the composition of continuous and integrable function is always an integrable on the given interval I. Agree? That is the requirement, and it is a very important result. So using this result, we can prove some propositions. That is, suppose F is integrable on closed table. Next proposition, if F is integrable on closed interval AB. F is integrable on closed interval AB, then mod F is integrable. If F is integrable, then mod F is integrable. This is the first requirement. How? So for its proof is, let phi equals phi of x or phi of t. Phi of t equals modulus of t. Phi of t equals modulus of t. Now listen, what is the modulus function? We know that modulus function is always continuous function. This is the graph of a modulus function. Modulus function is always a continuous function. So what is phi? That means phi is continuous. Phi is continuous. So phi is continuous. We know that here what is given? given f is integrable, and also we know that phi is continuous. Then with the previous argument, the composition of a continuous and integrable function is always integrable. So from here it is phi composition f is integrable. Phi composition f is integrable. What is phi composition f? Since phi of t equals modulus of t, what is phi composition f? Phi composition f of x equals modulus, phi of f of x, that is modulus of f of x. So phi of t is mod t. So what is phi composition f? That means phi composition f equals mod f. Okay. So phi composition f is integrable, but phi composition f is mod f here. So clearly mod f is integrable. So when f is integrable on AB, then mod f is integrable. That is proved by using, or that heavily depends upon the previous arguments. Okay. Now the second part is when f is integrable on AB, f of fn is also integrable on closed AB. How? Same argument. You define this phi of t equals some t power n only. T power. Phi of t is t power n. What is t power n? That's a polynomial. We know that polynomial function is continuous function. So what is f? Phi is continuous. Phi is continuous. F is integrable. So phi composition f is integrable. Here what is phi composition f? Phi composition f of x equals phi of f of x, that is f of x all power n. That means here phi composition f equals f raised to n or f power n. So phi composition f is integrable means fn is integrable. Finished. Okay. When f of x greater than or equals to delta, third case, when f of x greater than or equals to delta, then 1 by f is integrable on cos AB. F is integrable on cos AB with f of x greater than or equals to delta, then 1 by f is integrable on cos AB. How to prove that one? You define phi of t equals 1 by t. Since phi of t greater than or equals 1 by t, so phi is a continuous function. Okay, phi is continuous, phi composition f is integrable, so 1 by f is integrable. So these are proved by using this result. Agree? Clear? Then come to an interesting result. The interesting result is modulus of integral a to b f less than or equals integral a to b mod f. Modulus of integral a to b f less than or equals integral a to b mod f. How to prove this one? So we have plus or minus f less than or equals f. Okay. Plus or minus f less than or equals f. So that means integral a to b plus or minus f less than or equals integral a to b f. Clear? Integrating on both sides from a to b. Sure? So this means plus or minus integral a to b f less than or equals integral a to b f. Sorry, modulus of f or moreover. Modulus plus or minus f less than or equals mod f. So it is less than or equals this. Plus or minus f less than or equals mod f. That means integrating on both sides. Integral a to b plus or minus f less than or equals integral a to b mod f. Plus or minus integral a to b f less than or equals integral a to b mod f. So that means plus modulus of integral a to b f less than or equals integral a to b. Agreed? So this is a simple result. Thank you.